Alright guys, so just trying to save a little bit of class time, go over the quiz here that we had on Friday. So looking at the first page, the first question over here is going over correlation, which is hopefully something you guys have gotten. It says, which statement best represents the relationship between the two variables? So we've got an x and a y, and on each of these we have several dots going across. And basically what you're doing is just analyzing the representation that x and y have in common here, or is their relationship. So if you look at these dots on the first one, they're clearly going upward here in this direction, though they're not really very close together. So that's a positive correlation because you can still see, you could draw a line of best fit through the middle around here somewhere, but it's not really tight knit. So it's going to be a low positive linear correlation. Low correlation because that R value wouldn't be extremely high. It would just be a pretty low R value. Remember, the R value, the closer it is to a higher value, then the closer it is to 1, then the closer of a correlation that you have. So that's going to be 2, or Roman numeral 2, as opposed to this one, which is a negative correlation, obviously going downward in a negative direction, but everything's pretty close. I mean, you got one outlier over here, but that outlier is not totally bad. It's not throwing off all the data, and it's pretty tight-knit, so that is a high negative linear correlation. So that's going to be a Roman numeral 4. Roman numeral 5. Down here, the dots are just kind of spread all out. I mean, I guess you could draw a line of best fit, but it really wouldn't be very useful. So there's no correlation. That's a Roman numeral 3. And over here, once again, you've got a positive correlation going up, but it is pretty tight, so it's a high positive linear correlation. All right, so that would be a Roman numeral 1. All right. Number 2, and says the temperatures in degrees Celsius at midday were measured for Geneva. They're measured for 8 days, and the results are recorded below. And you've got one missing value that's a T here. The mean was found to be 7, so you can see we just set up a small average here. And this is a great example of how you should set up your work on something like this, because the T value being what you're, this shows the examined person for attempt points even if you make a mistake. So you would possibly get points even if you calculated incorrectly, but in this case, this person added them all together, multiply by 8, subtract the 46 over, and you get a value of 10. The mode is just the one that appears the most often, so that's 4. You can do that just by counting the number that are in here. And when you put them in order, you have a couple ways that you could do this. You could punch all these in the calculator and get a one variable stats going on it and see that the median is 6, or as you can see, this person here used typical method of the median, and there's an even number of values, so you just use the middle 2 and find the average of those, which in this case happens to be 6. All right. Number 3 is a cumulative frequency graph. So they give you the cumulative frequency graph, and they want us to find the median value. The first thing they want to find is the median. On the x-axis, you've got student scores, and on the y-axis, you have the cumulative frequency of the number of students that got those scores. And the median value, remember, anytime you're looking for the median or any kind of percentage or quartile, you're essentially going along the cumulative frequency value up here, and then in this case the highest value is 80, so you would go halfway to 80 and shoot straight across over to the frequency line, straight down from there, and you get a value of 30. So your median value score is 30. Okay, so in the middle of your data is about a 30. The interquartile range. The interquartile range is the difference in the range, or the difference in the values from the upper and lower quartile. So to get the upper quartile, see, you go up to 3/4 of 80, or 3/4 of the way to 80 is 60, and to the lower quartile is 20. So you take the difference, you go over to the line and find the two values, which in this case look to be about 45 or 46, and the lower value ends up being about, looks like maybe a little less than 20, so maybe 18, or actually maybe a little more than 20. Yeah, depends on how you would read it. And you pull it straight down, and then you take the difference of those values. And in this sense, I think the mark scheme gave a value of 23, but it gave a plus or minus 2. So they do give you a little bit of an error kind of way, because they understand that your graph is being done there by hand. But to find the 35th percentile, you take the 80, because out of the 80 cumulative frequency, you're finding the 35th percentile. So just like you find the upper quartile by doing 3/4, you find the lower quartile by doing 1/4. To find the 35th percentile, you do 35%, or 0.35, which gives you 28. And then you go up to 28 on the graph, go straight over and straight down, and that gives you a value of about 23 maybe. In this case, they got 24, and I'm pretty sure that, I haven't checked the mark scheme directly, but I'm pretty sure that that would be an acceptable value because it's within 1 or 2 of that number. Now, this is a little bit of a tricky one because it says the percentage of students who scored a 50 or above. Well, if they want a 50 or above, you have to go to the score of 50 or above and find where that 50 actually marks goes to, and you're going to go up on the line up to here, and that is going to be 70. Okay, and now if there's 80 total and 70 is where the kids that made 50 or higher is, then the difference there in that little section is 10. So you're not just doing the difference here. Well, in that case it would be the same answer, but you're not just finding the difference there, you're finding the difference between this value. Because look, if they gave you a score and they want to know the number of people, and remember the number of people is represented in the frequency, versus the scores that they made is represented on the x-axis. So the catch is that it's 10 people, but not 10%. So I saw some of you guys wrote 10%, and if you look on the mark scheme, there is a mark for attempt if you show 10% or 10 out of 100, but the correct answer is actually 10 out of 80, because there's 80 total, and 10 out of 80 gives you a 12.5, and that is represented to 3 significant figures, so that is a correct answer. You could have also given 0.125, I believe. I'll have to double check that though. Alright, number 4 says that 8 houses in the street are inhabited by different numbers of people as shown. And basically this is a one variable stats problem on your calculator. You're just doing a couple of little easy calculations. You shouldn't really be spending too much time. There's only a total of 6 marks. And remember, if we talked about there's a mark a minute, this shouldn't be a 6-minute question. This should be, a 2-minute question for you. And that saves you some time on other harder questions. So if I punch all these in, the letters really don't mean anything. This is not a count of the number of houses. This is simply a count of the number of people in A, in B, and C, and so on. So if I want to know the mean number of people, or mean number of inhabitants, then the total number of inhabitants is 39, and 8 of those people, there's 8 total items here, which gives me 4.875. Now there was some questioning on here about whether that's actually asking, because that is not equal to 5. If it wants you to find something that's rounded, it will specify to a certain number of significant figures or rounded to a specific amount. In this case, it is not equal to 5. The range is 4. That is true. So you take the highest value, which in this case is 7, and you subtract it from the lowest value, which is 3, to get the range. And the mode being the most represented number on the table, which is 6. Because remember, this is not a count of that many houses. This is just there's 6 people here and 6 people here. That's the most represented item, so that's going to be the mode. The standard deviation, this is a one variable stats problem. You put it in your calculator, crank it out, it gives you like 1.2 something, which even rounded is 1.3, and that is not 1.4. So to two significant figures, in other words, using the first number dot whatever is after the decimal, then that is not 1.4, it's 1.2. The interquartile range, if you do the one variable stats, it punches it in your calculator. It tells you that the upper quartile is 6 and the lower quartile is 4, and thus the difference between those two is the interquartile range, which is 2. You do not need to go in and do this by hand because your calculator, that's just a wasting your time. Like on a test, you're not going to want to waste those valuable minutes. Alright, number 5 gives you a table here of a bunch of IB students and things of that sort, what kind of grades they made, and if you list them out in order, as you can see this person did, then you can start getting some of these other things, or you could have just done one variable stats. So if you complete the frequency table, then all you have to do down here is just count the number of 4s, okay, or count the number of 2s, count the number of 1s, or whatever it is that's not filled in. So you just count the number of them and fill in the table. Write down the modal grade obtained by students. The modal grade is the grade, not the number, but the grade that was found the most, and that's going to be 5 of this number. So the modal grade is 6. A lot of you may have put 5, but the modal grade is 6. Even though 5 is the highest number, what does that represent? That represents that in this list of numbers there are more 6s than anything else. So a lot of times they'll ask for the mode, or the modal group, or the modal grade, or the mode of the number of students and stuff, so you have to be careful exactly what they're asking for. The median, again, this is a one variable stats. Hopefully you can just punch that in the calculator and see that the median is 4.5. I see this person did list it out by hand and did that by hand, but they could have probably saved a little bit of time on actual IB tests to just skip right into that. So let's find the probability here for part D that the student obtained either grade 4 or 5. Well, the number of students total is 20. It tells you that. You don't have to count them. So out of 20 students, if you made a 4 or 5, there's 4 5s, as confusing as that is, and 3 4s, as also as confusing as that is. So 7 total, and 7 out of 20 is 0.35, or 35%. And the last question is one where you're actually asked to fill out the rest of a cumulative frequency graph. So you are putting the cumulative frequency up here. So this one should have been pretty easy. You do 18 plus this 25 to get the next table, and then you graph those. When you graph those, and I actually have a small correction, so we said using the upper bounds. When I looked in the mark schemes, it's different than our textbook, and the mark scheme does want us to grade or graph it on 19 and on 39 and on 59, not on the upper half. I'm not going to count off, obviously, for that on this particular exam, but I do want to try to stay close to what it is that you'll see on the actual test. So I'll discuss that in class on Monday just to make sure. Notice that all of the graph here is done in pencil, and just as a double check, I checked you are allowed to use color pencils on the test itself, and you are allowed to use pencil on the graph. However, it is required that you use pencil. So some of you used pen on the graph despite the fact that you have the option to use pencil, and it should be required that you use a pencil, and I obviously will keep that in mind when grading this. I'm not going to take it out for this time, but now that we have that clarified, we'll make sure that that's taken into account. So the question here says write down the modal value, or write down the value of W. We did that, it's 43. Draw and label the cumulative graph, so you can see that they one of the things it specifies in the mark scheme is that it has to connect to 0, or it has to connect to the origin. So that's very important. Some of you started off here, and we did talk about in class how it does need to connect to the origin. So you want to try to make it as smooth and curvy as possible, and connect it to the origin. So it's determine the median number of cars per hour. Well, the number of cars per hour is represented in the cumulative frequency. excuse me, is represented on the x-axis, whereas the see here, cars parked per hour, excuse me. So it's determine the median, so you would say, okay, well, out of 100, the 50th mark is here. And in this case, that works out nicely because 100 is exactly half. And it goes straight across, over and down to about almost 70, so like 67 and a half or 67, which this person correctly, you can have 67 and a half cars, so 68 cars parked per hour, and I believe the mark scheme will give you a plus or minus on that as well. So take a second, look back over your quiz, or look back over the mark scheme and look back over this video if you need to, and ask me additional questions on Monday. But if you do have specific questions that you think will take a while, let's try to save a little bit of time and come and see those individually. Alright, peace out.